talk a little bit about some algebra review stuff today and how we can simplify things and make things look nicer. Part of what I wanted you guys to do over the weekend was read through some of that first section, and there is some talk about what like the simplest form looks like, right? It doesn't always have to be simplified, but there are times when the directions are going to say you need to simplify this, or it's a multiple choice question which has been simplified, so you got to find it that way. And one of the major things that we need to do when we factor is go through the process of GCF and special products and all those weird things. So again, what are the steps to factoring? Step number one, look for a greatest common factor, right? Always. There may be one, there may not be one, in which case we look for special products. The one that we're probably most familiar with is something like one of these. An example of that, x squared minus 9, which would factor to be exactly. Of course. The next one, the perfect squared trinomials. What are those? Well, it's something like that. Now, if I asked you guys to factor that, you probably wouldn't think of that as one that you would memorize. But you could, because x minus 3 times x minus 3 gives you x minus 3 squared, and so this is what's known as a perfect squared trinomial. There are some indifference of cubes. These we'll talk about later on this year. We're not going to really review that all that much right now, but we will. So we talked about the factorable trinomial. That's this. Guessing and checking. Guessing and checking is where you throw things in and keep going until you find one that works. Grouping. What's another word for grouping? Split the middle. Split the middle. Synthetic. Synthetic division, you guys did synthetic last year, right? Putting the number in the box and the coefficients and all that, right? So just some things that we need to do, and we're going to be doing a lot of factoring, of course, right? You're not surprised by that. So if I give you one like this, pretty simple example, we would take an x out, because we know that GCF is our first step. And that would leave us with one of these on top. And the bottom being factorable itself is a trinomial. X minus 3 and x minus 4, right? And some things would reduce. So these x minus 3s would reduce, leaving me with this. So quick question here, guys. Cheyenne, is that Cheyenne, right? Is that simplified? Or is there anything else I could do? It is. Yeah, it is simplified. Would you guys agree that this is a product on top? And would you agree that this isn't written as a product, but I could do like this if I wanted to and write it as a product? So I have two things that are being multiplied. Here I have two things that are being multiplied. And the only time I can ever reduce is when things that are being multiplied are the same, right? So a really common error, guys, would be to get to like this point right here and be like, yeah, I can cross those out. Why can't I not cross those out? Because on the bottom, I'm not what? I'm not multiplying this x with something else, right? It's just x minus 4, and x minus 4 is a term within itself, right? Cool? Cool. Down to the bottom. So that was too easy. So now we look at something that has a little bit more to it. GCF is always our first step. So if I look at the top, I'm taking a 4 out. And on the bottom, I'm taking out the 2. So that's good. But now I have how many things in the parentheses on the top? Too many. I have 4 of them, right? And what you guys should be thinking about is a technique known as grouping, right? With grouping, I'm going to take those 2 groups of numbers, right? Guys, right now, do me a favor. I'm like ignoring all of this, okay? I'm only focusing on how would I factor this, okay? What can I take out of those first 2 numbers as a greatest common factor? X squared. So I take out an x squared. And when I take an x squared out of both of these, what am I left with? An x minus 2. Oops. Then I always keep the sign of what is between the groups. This sign will always stay. And then I look at these 2, and what can I take out of those? A 5, right? So I'm really taking out a negative 5. So negative 5 goes into this group and leaves an x and a negative 2. Now, please remember, guys, that when you group, right, that's the first step. The second step is then to take that common factor out of each of the groups, right? So what does that look like? Well, what was the common factor between the 2 groups? The x minus 2. And then what's the leftover stuff when I get rid of the x minus 2's? The x squared minus 5. And I got one too many. I have one too many sets of parentheses in the top. It doesn't matter. That's okay. Associative property, right? Doesn't matter if this set of parentheses is here. Yep. You could have. The problem would have been, what would you have synthetically divided by? I see what you're saying. You're saying if I had taken out the GCF, reduced these 2's, and synthetically divided 2 into it, could I have gotten the same results? Yeah, that would work. That would be another way to do it. Yep. X minus 2 going to reduce. 2 goes into 4 twice, leaving me with that. That cool? All right, so reviewed a lot there on that one, right? Talked about a lot of different things. All right, so what does this say? It says already our level of sophistication is increasing. Look at that. So now we're on a problem like this. And again, this is a version of an expression. It's not an equation. Remember that, guys. Sometimes people like to solve things that aren't equations, right? They start setting things equal to 0 without having any reason to. I just want to simplify this. In order to combine fractions, I need common denominators, right? So there's a couple of different ways that I could solve this problem. I'm going to show you one of them. If I want to focus on the numerator and the numerator only, to put these 2 fractions together, would you guys agree that 5x is the common denominator in the numerator? So I went from x to 5x. So what do I need to change the top of this first fraction to be? A 5. I went from 5 to 5x. So what do I need to add to the second fraction? An x. So now that I have a common denominator, I can put those 2 fractions together, right? So that's going to be 5 minus x all over 5x. Got that? All right, now let's look at the bottom. What would be the common denominator of the bottom? 25 x squared. What do I need to add to the first fraction that wasn't there to begin with? 25. And to the second fraction. And now that I have a common denominator, I can put these 2 together, right? How many fractions do I have in the numerator? How many fractions do I have in the denominator? Let's go eat at keep, change, flip. KFC, but it's like, I don't know, somebody messed up when they hung the letters. I don't know. Really? So it's going to be 5 minus x over 5x times 25x squared over 25 minus x squared. What did I do? Kept the fraction on the top the same, changed the division to multiplication, and flipped the denominator, right? Keep, change, flip. Now what? Well, now I can, just said it 2 seconds ago. Remember, we're not solving an equation, and the only time we cross multiply is when I have a comparison of two fractions. Fraction equals fraction, we do a cross product. This problem is a multiplication of fractions. Multiplication of fractions is multiply the numerators, multiply the denominators. But because we're trying to simplify, what should we do before we do any of that? Reduce. And how do we reduce these? Factor and find things that are the same vertically or diagonally, right? So if I have things that are common up and down or diagonally, I can reduce them. You can never reduce left and right. Agreed? Okay. So can I factor anything up here? Yeah, just this, right? So that's going to be 5 plus x and 5 minus x. So what can we reduce? Well, we got a whole bunch of stuff that we can reduce. This 5 minus x and this 5 minus x, because now it's being multiplied, right? How about this 25 and this 5? Absolutely. How about this x squared and this x? So what's left? 5x on the top, 5 plus x on the bottom. This 25 and this 5 reduced to be 5, and x goes into x squared x times. What's x squared divided by x? So I just reduced. Basically, guys, I took this, right? So the 25 and the 5 divides to be the 5, and x squared divided by x is x. Can I reduce any more of that, or is that it? That's it, right? Yeah, I'm done. That's it. Okay. So what do we have there, guys? There we had an example of some complex fractions, right? And then doing some reducing of rational functions, okay? So that was like 2 units that you guys did last year. Ugh. What is this? It's so gross. Here I got like, oh man. Oh, I did hit it. Oh, good. Here I have negative exponents. Do we like negative exponents? No, we talked about this the other day, didn't we? I keep forgetting if I talked about this with you guys. Okay, so how do we deal with negative exponents? I'm going to give you guys a really, really cool way to remember this. If I say x to the negative 2, we don't like those. Can you guys make this a fraction right now, right this very second, without even thinking about it? Your brother who's in 4th grade would say yes. That your brother in 4th grade has no idea what that means. Any number can be made a fraction by putting it over 1. So where's the negative exponent? In the numerator or the denominator? So to make it positive, all it has to do is get on the elevator. Has to go to the other floor. That's it. So if I gave you this, where's the negative exponent? on the bottom. So to make it positive, it just has to get on the elevator. If I did a combination of both, maybe if I did this, got some exponents in the numerator, got some exponents in the denominator. Some are positive, some are negative. A squared has a positive exponent. So what's it gonna do? It's gonna stay. B to the negative second power is in the numerator, so to make it positive, it's gonna take the elevator. C cubed is positive, so it's gonna stay. And D to the negative fifth is negative, so it's gonna take the elevator. Easy way to remember it? Okay, so let's go to this problem. Because now these problems over here look nothing like what we just talked about. So, guys, remember that the negative exponent could be on one term, it could be on a number of terms, right? Here it's on a set of parentheses, right? Okay, I want you to pretend like none of this is here. I just want to focus in on one thing and one thing only. What is being raised to the negative exponent? The x minus 2. Do you guys agree that I could change that to be x minus 2 to the negative 1 over 1? Now it's a fraction. So if I want to make the exponent positive, I'm just going to move that x minus 2 to the bottom of a fraction. In other words, it's going to look something like this. The 3 is not going to move. It has nothing to do with the negative exponent. Minus 6 over x minus 2. Now before you breathe, do you guys agree that this 6 could be put over a 1? Which could also be put next to this. So in other words, watch. Isn't that really what I have? So to make this positive, I drop this to the bottom, and can I just put these two fractions together because multiplying by 1 just leaves whatever it was as it is, right? So is everybody cool with what I just did now? So what is this one going to become? It's going to become 6 minus 12x over x squared minus 4. All right, do you see what happened? This is 12x over 1. This is this over 1. So now it's going to be 12x over 1 times 1 over x squared minus 4. Well, that 12x times 1 is 12x. That 1 times x squared minus 4 is x squared minus 4, and that's how we get that. Do you see it? Cool way, though, right? We don't have to deal with the negative exponent, at least. Kind of nice. Now, what do we not like about this? Everything. There's all kinds of stuff going on here. I have multiple fractions. Why don't we do what we did on the last problem? So I'm going to create a common denominator here. So I'm going to just look at the numerator. I'm going to do x minus 2. I'm going to change the first fraction to have a denominator of x minus 2 because right now the first fraction is over 1, right? So now it's going to be 3 times x minus 2. Minus 6 over x minus 2. Don't have to change that one at all, do I? All over. This is over 1, right? So my denominator has an x squared minus 4, so I need this to be an x squared minus 4. All right, again, it's like magic math, right? It's like, holy cow, you're throwing things over here. No, guys, I just multiplied this by 1, right? But I used the common denominator. Now I have two fractions and two fractions, but they both have common denominators, so lucky for us. And I did a little bit of quick math there, guys. See what I did? Did my distribution, minus 6. Did my distribution, combined it with that. But the good news is now I have what? 1 fraction divided by 1 fraction, and we can go eat at KFC. So we have 3x minus 12 over x minus 2 times. Oh, hang on. Gotta flip it. And we get one of those. And guys, it's going to be the exact same process as the last one, right? So we'll do some factoring, we'll do some reducing, we'll make it look pretty, and we're on our way. Okay. I'm going to stop that one there, okay? I'm going to skip over example 5. I want to go to example 6. Trevor, don't like this problem at all, do we? We don't like it because it's got a what and a where? A radical in the denominator. Do we like radicals in the denominator? No. Okay. So let's talk about something like this, a really easy one. If I gave you 3 over radical 2, don't like that radical, do we? How do I get rid of it? Multiply by, well, really multiply by 1, right? Radical 2 divided by radical 2 is 1. So what do I get? That gives me 3 radical 2 over radical 4, and the square root of 4 is 2. So I wind up getting 3 radical 2 over 2, and now it's something that we like. Why does that work? Well, it works because I'm multiplying a radical by itself, and when I do that, what happens? The radical goes away because any radical times itself is whatever is underneath the radical, right? Okay. So how do I deal with this one? Multiplied by the whole denominator? Sort of. You're right there. What's that called? Conjugate. So to rationalize these, we multiply by the conjugate. And guys, if I say a plus b, the conjugate of a plus b is a minus b, right? So all I have to do is change the sign of the thing in the middle, not both, right? A lot of people will say I'm supposed to change both signs. I don't know. I'm trying to draw something there. It's not working. Conjugate. A plus b and a minus b. So I have 1 minus radical 5. I want to get rid of the radical, so what I'm going to do is multiply the top and the bottom by 1 plus radical 5. Just change the sign. So my numerator, Michael, to multiply fractions, it's just going to be 4 times 1 plus radical 5. And the denominator is going to be 1 minus radical 5 times 1 plus radical 5. How do I multiply the bottom? What's that called? FOIL. If you've had me before, you know that I don't like FOIL. I like tic-tac-toe. So because that's what you just multiplied by, right? 2 steps forward, 2 steps back, means you didn't really move anywhere. I like your thinking. I do. You guys know how to play tic-tac-toe? Raise your hand if you know what I mean by tic-tac-toe. Okay, if you don't know what I mean by tic-tac-toe, it's a technique that I like to use only because when we start multiplying things that are more complex, it's going to make it a really easy way to do it. Anytime you're multiplying 2 things times 2 things, or 2 things times 3 things, or 5 things times 4 things, I have 2 and 2, so I do 2 lines down, 2 lines across. This is always a blank box. This is 1 plus radical 5. This is 1 minus radical 5. The boxes that line up get multiplied, and your result is what's in here. So what's in this first box? 1 times 1. This is 1 times radical 5. This is 1 times negative radical 5. And this is radical 5 times negative radical 5. So what happens with radicals? They go away, but in this case, I had a sign change. What happens with the radical 5 and the negative radical 5? They cancel out, so what's left? 1 minus 5, which is negative 4. So I have 4 times this over negative 4. What happens to the 4 and the negative 4? They reduce, and I'm left with that. Now we have more that I want to do with the reducing and rationalization of these radicals. Okay, we're going to see more of that. If you flip to worksheet 3, I believe there's 32 questions on worksheet 3. You're only going to do the first 16. First 16. Okay. Again, guys, you're going to see